In this video, we're finding the angle between two vectors that are given in I hat, j hat notation. So our first vector is this vector v, given as negative 3i hat plus 2j hat. And we have a picture of it over here on the graph paper. We can see that if we start at the origin, we go 3 steps to the left and 2 steps up to plot that vector v. Our second vector is w, and that's given as I hat plus 4j hat. So we go 1 step to the right, 4 steps up, and we've got our vector w. Now we have some angle between them that looks somewhat less than 90 degrees, and we're trying to nail down exactly what that is. And the whole idea of the problem is to use the dot product to get this done. So we remember this geometric definition of the dot product, that if we take v dotted into w, we get v times w, the magnitude of v times the magnitude of the vector w, multiplied by the cosine of the angle between them. Now, if you're in a Calculus 3 class, you're probably used to writing these magnitudes in a way more complex way. So just a heads up, in a Calculus 3 class, that would be written as double absolute value bar vector v to tell you the magnitude of v. But I'm doing this problem in a physics class, and physicists are a lot more concerned with economy of notation. So if you just write the symbol v, that means the length of the vector v. All you have to do is remove that vector over the top, and you're communicating that you're talking about the length of the thing. All right, so the strategy here is that we need to find the dot product between these two vectors. We need to find the magnitude of each vector, and then theta is the only unknown that's left. So let's go ahead and just solve for it symbolically first. If I solve for cosine theta, I get v dot w over v times w, where again, those mean the magnitudes of those respective vectors. Then we solve for theta using an inverse cosine. So theta is the angle whose cosine is v dot w over magnitude of v times magnitude of w. All right, so now we have to get these individual calculations done. So now the dot product of these two vectors that are given in component notation is found by taking the pairwise products of these coefficients of I hat and j hat and just adding those up. So when I do the I hat part, I get negative 3 times 1. That gives me a negative 3. I do the j hat part, that gives me a 2 times 4, so we get negative 3 plus 8. And the dot product turns out to be 5. That's just a scalar. Remember, the dot product takes two vectors and smashes them together, and the output is a scalar. Now the magnitude of v, you just use the Pythagorean theorem for that. That's the square root of the sum of the squares of the components. So I end up with a square root of 3 squared plus 2 squared. Notice that I didn't bother writing the negative 3 because I know when I square it, I get a positive number anyway. So I end up with a 9 plus 4 on that square root, and the magnitude of v is square root 13. Now we do w, and that gives me a square root of 1 squared plus 4 squared, and that gives me square root 17. So we go back to our calculation of the angle. It's the angle whose cosine is the dot product of v and w, that's 5, divided by the product of the magnitudes of the two vectors. So that's square root 13, square root 17. And when we smash the numbers into a calculator and just round to 3 significant digits, we get something like 70.3 degrees. And the whole reason I included a plot of these two vectors on this graph paper is because it's wise in a problem like this to make sure the numerical answer looks something like what you're seeing in the picture of the two vectors. It's certainly plausible from the picture that this is an angle of 70.3 degrees. Again, it appears to be bigger than 60, less than 90. So our answer is reasonable, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.